welcome back. We have started looking at structured knowledge, or as knowledge structures that I like to say, and we want to focus our attention on scripts for the moment. Now, whatever I am going to talk about, I have basically taken from this book called Inside Computer Understanding by Roger Schank and Christopher Riesbeck. And in particular, this chapter, which is on a program called SAM, which stands for Script Applier Mechanism, which was the PhD work of Richard Cullingford essentially. So, Roger Schank had what should I say, an army of students, each of who looked at different aspects of building a complex natural language understanding system, focusing on the knowledge which goes behind natural language understanding. So, scripts are basically a collection of episodes. SAM, which is the script applier mechanism, the program that we are talking about, reads stories in a top down predictive manner. So, the moment it knows that this particular script is active, it knows what to expect. It is like when you go to see a football match, you already know what to expect essentially, right. I mean, you do not know who will score, but you know that people will try to score essentially, that this is how teams operate, they pass to each other and that kind of stuff. Like most of the work in Yale at that time, Sam reads newspaper stories about situations describing motor vehicle accidents, plane crashes, train wrecks, oil spills and state visits. So, in a sense, when we do representation like this, we are doing it in a very domain specific fashion, that we are going to represent knowledge about particular kinds of situations. So, for example, vehicle accidents or restaurant visits and so on. So, our programs will be good at that, but they will not be able to understand stories which do not fall in the scope of what they already know essentially, which, as you can imagine, is to be expected. So, we use the word situations here. So, situations are in some sense bigger than scripts. Scripts are parts of situations. So, scripts are aggregated into situations, and you can see that this whole process of aggregation has begun from the very fundamental particles that we talked about, or fundamental events if you want to talk about events. And then as we go up into the aggregation hierarchy, we talk of things at a different level of granularity. So, scripts and situations and scenes, as we will see, are different levels of granularity at which we can talk about this kind of hierarchy. Schank used to call it as packaging hierarchy, because you are putting together sets of sentences and packing them together into a script. We will call them aggregation hierarchies, but we mean the same thing. So, later on something called MOPs, which is memory organization packets, came up essentially. We will see, I might try to give you an example of that. So, a script is a pattern of connected conceptualizations. We already know what do we mean by conceptualizations. This is a two-way dependency between concepts, as we studied in the CD theory. Now, a script is a pattern of connected conceptualization. So, there are many, it is not just one, and they are all connected to each other. There is a sequence typically, and we have roles and we have props. So, by roles we mean exactly like roles in theatre, that somebody is playing Macbeth and somebody is playing someone else and so on and so forth. So, there are roles, there are characters in the play, and like that in scripts also there are characters who do specific things inside scripts. So, for example, a cashier at a cinema theatre is a role, and props mean objects which are there in the system. Because we are working with scripts which organize this knowledge about typical situations, we are able to generate expectations. These are pre-stored expectations about what will be read next. We will see as we go along. So, here is an example of a subway script. By subway, we mean something like a metro train. So, we have described it at two levels. One is at the level of episode, the other is at the level of conceptualization. So, at the top you can see that a patron enters the station, which is represented as a patron group P transit to inside part of the station. So, we have given a rough this thing. Then they go through a gate, either they go through a gate directly or they buy a ticket and go through a gate. They go and wait at a platform. A train comes, but maybe that is not the train that the patron wanted. So, they wait for the next train to come. So, there could be a cycle there. Then they get into a train, then stations start coming, and they might again wait till the destination arrives, and at some point when their destination arrives, the patron leaves the station and exits from the station essentially. So, which can be represented as the patron group P transits from the station outside. So, this pattern of connected events is what Shank calls a script essentially. So, what is this script? Let us do a very quick recap. At the top level, we are seeing that somebody enters the station, then there are two branches, that either you go directly to the platform or you first buy a ticket and go to the platform. And we know that both models apply in most of the kind of travel we do nowadays. Then you go to the platform and wait. A train comes. If it is not your train, you wait for the next train to come, and so on. At some point, you get into your train, then you wait for your station to arrive, your destination to arrive, and when it arrives, then you get off and leave the station. And this is a typical subway script. By subway, we mean metro essentially. Metro, like local trains as we call them in many places. So, story reading, as we have said in SAM, is predictive. You read the first sentence and somehow you figure out what is the script that we are talking about. So, the script is a collection of episodes essentially. As you can see, we have identified one of them. The rest of them become expectations as to what is it that we could be hearing about in this story. And then the next sentence comes in the story, and our task is now to match it with one of the episodes in the script essentially. As we can see here, we have matched it with the fourth element in the script, and then the last sentence of the story comes and we have to match it with another episode in the script, and that is what we have seen. So, we have three episodes in the story and they respectively are mapped onto the three episodes in the script. So, typically when we tell stories about typical situations, you do not describe everything at every level of detail. So, if I were to tell you that I went to the canteen and I had a dosa and a coffee, that much is enough for you to figure out what happened. You will figure out, because you know what happens in a canteen. For example, in IIT Madras canteen, you go to the canteen, you stand in the queue, and then you pay the cashier gives you a token, you take the token and go to the counter, and at the counter they take the token and give you whatever you have bought essentially. You already know this. So, I do not have to say all that essentially. All I need to say is, I went to the canteen and I had a dosa and a coffee, and you understand what is happening. You know that I would have paid and I would have eaten the dosa hopefully, and we will see examples of such stories. So, the whole game in knowledge representation is about making inferences. We have spent a lot of time in the course on deductive inferences, but not all inferences are deductive in nature. Many of them are abductive in nature, in the sense that we make inferences which are likely to be true. Not always abductive, maybe probabilistic also. So, one of the inferences that you can make when you are processing scripts is causal chain completion, which means inferring the intervening events that must have taken place between the events explicitly mentioned in the story. So, if the story has just 2 or 3 lines, but the script has 20 lines, then you know that most of those other things would have happened or most likely happened. So, we want to maintain a causal and a situational continuity. So, for example, if I tell you that I went to the cinema and I saw this film, you know that I would have bought a ticket and then I would have showed the ticket and only then he would have left, the doorman would have let me inside and so on. We can fill in all that stuff because of the fact that we have this background knowledge represented in the form of scripts. So, the second kind of inference you want to make is role instantiation as to which person, let us say we are talking about people doing things, is playing what role in the script. So, there is a patron, there is a cashier, there is a bus driver and things like that. So, we have to identify as to the story that we are reading, what person fits into what role. Not only that, we have to also worry about role merging, that sometimes we may refer to that person using different noun phrases, and we should have the capacity to realize that we are talking of the same individual. So, recognizing when multiple references to the same specific role filler essentially. So, here is a small example of a 2-line story. The line in the middle is not part of the story. The story is simple. John walked into the subway station. He went to the express platform. That is all that is said in this part of the story. But the first thing, that causal chain completion, that you can fill in that he must have bought a ticket, or of course, he must be having a pass or something like that, which allows him to travel let us say for a long period of time. Then we have to do role instantiation and role merging. So, John is a rider in the script. There must be a ticket window, props we can recognize, gates to platforms and all that kind of stuff, which is there part of the subway script that we just saw. And also role merging. So, when he say he went to the express platform, we must identify that he is John essentially, and he is doing an action which is predicted by the script essentially. So, here are some more implicit inferences. John went to the movie theater. He went to the ticket counter and asked for a ticket. So, imagine that this is the verbatim story that is being told to you or to this program called SAM that we are talking about, and then we want to see how much the program has understood. So, assuming that we have a theater script, when he says he went to the ticket counter, then in the script there would be an episode which says that you go to a cashier or you buy a ticket from a cashier. So, cashier and ticket counter are going to be related to each other, and the program should figure that out. From the continuity point of view, the patron is expected to buy a ticket at this point, because he is asking for a ticket to start with. As I said, the cashier sits at the ticket counter, and that is a situational inference that the program can make, because the script might say that you buy a ticket from the cashier, because it is a counter essentially. Otherwise, it could be a vending machine, which is a different thing. And we can kind of infer that the patron must have paid for the ticket essentially. So, essentially I hope by now you are getting that idea of what scripts do. They give you all this background knowledge in the form of some large pattern, and you are reading in sentences and trying to match them into the pattern essentially. So, here is an example of SAM. This is an actual example run by SAM. John went to a restaurant. He ordered a hot dog. The waiter said that they did not have any. He asked for a hamburger. When the hamburger came, it was burnt. He left the restaurant. Okay, this is all that is told to you explicitly, verbatim. Now, SAM works only with conceptual dependency representations, it does not work with English. That job is given over to LE, which is the English language interpreter that we had mentioned earlier, which we also used when we were talking about uh, conceptual dependency. And text generation is done by a program called Babel essentially. Now, question answering was done by, I had mentioned this earlier, by Wendy Lehnert, and her whole PhD thesis was on how to make sense of questions and how to look for answers in what you know and give out the answer. So, her job was to understand the question and find the answer. Understanding the question was done with the help of LE. Conveying the answer was done with the help of Babel essentially. And the source for the answer was the story generated by Sam. So, this is the same story that we were talked about, and let us look at some of the questions that Sam could answer in between calling LE and this question answering system by Lehnert and a text generator called Babel. Did John sit down in the restaurant? The answer from the system is probably. Did John order a hot dog? The answer is yes. Did John eat a hot dog? The answer is no. The waiter told John the management was unable to give it to him. It was not available. What did the waiter serve John? The waiter served John a hamburger. If you look at the story, it says when the hamburger came. It does not say the waiter served it to him, but because you have the script and you are working with the script, you know what is happening. Why didn't John eat the hamburger? Because the hamburger was overdone. Did John pay the check? No, John was angry because the hamburger was overdone and so he left the restaurant. So, a little bit of guesswork here that he did not pay for the. Here is another story. We will look at this and then take a break. This is a motor vehicle situation. It contains scripts. So, it has a car accident script, it has an ambulance ride, hospital treatment, police investigation. All these are part of the motor vehicle accident situation. So, just read this story. Friday evening, a car swerved off Route 69. The vehicle struck a tree. The passenger, a New Jersey man, was killed. David Hall, 27, was pronounced dead at the scene by Dr. Dana Blanchard. Now, Sam has to figure out the passenger was killed and the passenger who was a man from New Jersey was killed and David Hall was pronounced dead. So, this role merging, if you remember, has to be done. Also, Frank Miller, 32, of 593 Foxon Road, the driver, was taken to Milford Hospital by this ambulance. He was treated and released. No charges were made. Patrolman Robert Onofrio investigated the accident. So, we do not say that he was injured, Frank Miller, but we do say that he was taken to the hospital, given some treatment and released. So, like in Margie, Sam can also paraphrase the story for you, and this is a story that is generated by Sam. An automobile hit a tree near Highway 69 4 days ago. David Hall, age 27, resident in New Jersey, the passenger died. Frank Miller, age 32, residence at so and so in the New Haven, Connecticut. The driver was slightly injured and the police department did not file charges. There is a Spanish summary available also, but I have not included it here. Maybe later I will show you one. So, let us look at how question answering is happening for the same story. Was anyone killed? Yes, David Hall died. Was anyone hurt? Yes, Frank Miller was slightly injured. Slightly because he was given some treatment and released. Why was Miller hurt? because the automobile hit the tree essentially. Did Miller go to the hospital? Yes, he was in the Milford hospital. How did Miller get to the hospital? The Flanagan ambulance company took him essentially. So, these are the answers generated by Sam, and the fact that he was injured in the car crash is not stated explicitly, but because now we know that we are operating in a script, we know that. We also are able to make the connections between the vehicle and the car and the New Jersey man and David Hall, as we have seen essentially. So, this I hope gives you an idea of how scripts operate, and we shall come back and look at a little bit more detail into scripts, then we will see a more detailed example. So, see you in the next session.